Okay, so today we are going to talk about interquartile range. So what is interquartile range? That is, it is calculated by subtracting the first quartile from the third quartile. It is the range of the middle 50% of a distribution. So I know we talk about range being the full distribution, so the largest minus the smallest. This is talking about quartiles, which actually break the data down into smaller pieces. We're going to talk a little bit more about quartiles. So what is a quartile? A quartile separates the data further into smaller sections. So there are 3 of them, which means that they split the data into 4 equal parts, which are 25% of the data. So we have the lower quartile. We abbreviate that to Q1, meaning quartile 1. Okay, it's actually the median of the lower half of the data. So our Q2, or our median, splits the data into half. So then we have 50% and 50%. So Q1 would just split the lower half in half again. And then same thing with Q3. It splits the upper half of the data into 2 pieces. So in order to find our interquartile range, our first step is to actually find the median. So whenever we're finding the median, it's super important to think about our first step. So our first step is always, now in this case, this data is in order from least to greatest, but it's important to understand that anytime we're given data, it doesn't mean that it's going to be in order from least to greatest. So it's important to put it in order from smallest to largest. Okay, so we are looking at data from a 50-meter dash. So we want to find the median, and the median is the middle value. If there are 12 total data values, that means that there are 6 on either side of the median. So the median is going to be right in between the 6th and 7th data value, which is in between 10 and 6/10 and 10 and 8/10. What number is in between 10 and 6/10 and 10 and 8/10? It is 10 and 7/10. So then our median is 10 and 7/10. All right, so after that, now what we need to do is we've split the data into 2 parts. Each part has 6 pieces of data. Now what we're going to do is we're going to look at the same data again, but this time we need to split it into even smaller pieces. So we need to split this lower half of data into 2 parts, which is where Q1 comes into place. And then that gives us 10 because the middle of 9.5 and 10.5 is 10. And then we want to look for Q3, which is going to split the upper half of the data in half. Okay, so if we have 6 data values, there's going to be 3 in each. So we're going to have 1, 2, 3, and then our Q3 should be right in between 11 and 4/10 and 11 and 6/10. What number's in between 11 and 4/10 and 11 and 6/10? Hopefully you guessed right, with 11.5 or 11 and 5/10. All right, so now that we have found Q1, the median, and Q3, our next step is to go ahead and find our IQR. And the IQR is just the difference. Hopefully you know that means subtraction. The difference between Q3 and Q1. So all we have to do is take this 11.5 and subtract 10. And when we do that, we get 1.5. So the IQR is 1.5. All right, so let's try one. So we have this data set that is talking about the average height of each sixth grade class. So remember, our first step is to do what? Find the median. In order to find the median, we have to put the data in order from least to greatest. And then we can cross off till we find the middle, and our middle is 54. After that, we need to find the upper and lower quartile. So if we look at Q1 first, over here we have 3 data values. So which one's in the middle? Hopefully you guessed right at 52. All right, and then same thing for Q3. We have 3 of them. What's in the middle? Again, hopefully you guessed right at 57. Okay, and then our last step is to go ahead and find the difference between those two. So we just need to subtract 57 and 52, and we get 5. So our IQR is 5 in this case. All right, last page. So really, I just want to talk about IQR and why it's important and what does it tell us. So it tells us the spread of the middle 50% of the data. Why is that important? It's important because sometimes with range, we have values that are super, super high or super, super low. Where if we just talk about the middle 50%, those numbers are a little bit closer to that center value that kind of tells us a lot about the data. And like I said before, it's less affected by the outliers because we're talking about the middle 50%. Okay, and it's telling us the spread, meaning how spread out are these data values.